A shot is fired from the top of a cliff 200 meters high with a velocity of 500 meters per second at an elevation of 30 degrees. Find the distance from the bottom of the cliff to the point where the shot strikes the ground and the time taken. And then also we need to find the distance from the ground to the highest point created. This is the question we will be answering in this session. Thanks for tuning in. My name is Arnold Rangakuramia and this is Kisembo Academy. I like to summarize my questions with a diagram, so let's get to it. Okay, so right there we have a shot. It's fired from the top of a cliff. So this is the cliff we are talking about right there, and this is the shot. It is fired from the top of a cliff 200 meters high. So the cliff is 200 meters high with a velocity of 500 meters per second. So it is fired like that with a velocity of 500 meters per second. So meaning our value of u here is 500 meters per second. Yeah, and at an elevation of 30 degrees. So while it's being shot, it is shot at an angle of 30 degrees to the horizontal, like that. So it is shot like that. So they're telling us find the distance from the bottom of the cliff. Here is the bottom of the cliff. They want us to find the distance from the bottom of the cliff to the point where the shot strikes the ground and the time taken. So it comes, the shot goes to the ground here. We need to find the distance from the bottom of the cliff right here to, we need to find this distance. That's the first part. To the point where the shot strikes the ground. So the distance from bottom of the cliff to the point where the shot strikes the ground and the time taken. Also we need to find the time taken for the thing to move from here up to there. That's the first task. Then they want us to find the distance from the ground to the highest point reached. That is Roman 2. This is the highest point reached. They want us to find this distance as well. Let me call it h. It's also needed. So those are the things that we need to calculate in this question. So let's get started with Roman 1. We want to find the distance. This is now like horizontal displacement. Now one thing that again I'll keep emphasizing is that now here we are going to solve this using equations of motion, more like from first principles. We will not be able to apply the derived formulas in their entirety. So let's get started. We need to find this distance here, and as far as this is concerned, this distance here is the horizontal displacement x. So this is the horizontal displacement s in the horizontal direction. By the time this comes and drops here, this is the point of projection, and if this is the point of projection, it means that this is our zero level. And if that is our zero level, okay, so by the time this point goes up, it gets negatively displaced when it's here. Our displacement between here and there is what they want, the displacement in the x direction. And then from here to here in the y direction, what is our displacement here? Our displacement in the y direction here is, because it is falling below the zero ground, below the point of projection, it is 200 meters. So this is negative 200 meters. Okay, so in the negative sense, by the time it hits the ground, it will have gone down by 200 meters. We need to find the distance or the displacement in the x direction by the time it is here. So we are going to use the second equation of motion to find this value of x. So we shall begin from the known to go to the unknown. So we know that the displacement in the x direction is that, so we shall come and say s in the y direction. That is going to be ut plus a half gt squared. So displacement in the y direction is negative 200 meters is given by initial velocity u. Now the initial velocity here u is 500 meters, but it is at an angle of 30 degrees, and since our displacement, we are working it out, displacement in the y direction, it means that even our initial velocity should be resolved in the y direction. So it means it's this, in this case u is going to become this. It will be u times the sine of 30. We are resolving it in the y direction, times the time taken. Yeah, then this is going to become plus a half. The gravity is negative because it's moving against gravity. It's minus g times t squared. So we shall go ahead and fill in the figures. Minus 200 meters is going to be u is 500, so it's 500 times sine of 30. Then this is minus 9.81 over 2. So this is going to end up being negative 200 is going to give us minus 4.9 t squared. If we are to rearrange this quadratic equation, this t, bring it that way, this one also, take it that way, we shall end up with 4.9 t squared minus 250 t minus 200 is equal to 0. So when we solve that quadratic equation, either using the what we call the bulldozer method, or call it the quadratic formula, we shall end up with two values of t. The first value of t will be 51.7, and the other value of t will be negative 0.79. Of course, we do not have negative time, so we shall go on with the first value of t, so that's the time taken. So from our vertical displacement, using this formula, our vertical displacement, we're able to find the time taken for this to move from here to come to that point. Actually, we have solved this part, the time, by just doing that. So we know that the time taken is 51.76 seconds. So now that we know the time, we can go ahead and find Sx, the horizontal displacement. So we shall go on and say here that our horizontal displacement Sx is still given by ut plus a half gt squared. Our Sx, displacement in the x direction, which we are looking for, the distance from, the bottom of the cliff to where the stone lands, which is this one, right? Yeah, is given by the initial velocity u is supposed to be resolved to the x direction, because now we are looking at displacement in the x direction. So this value of u needs to be resolved in the x direction, and in this case it's going to become u cosine of x, multiply that by t, then that's going to become plus. Now in the x direction, remember I said in the x direction we do not have gravity. In the x direction, gravity happens in the y direction. In the x direction there is no gravity, so this is 0, and so it means this whole term is 0. So we only remain with this plus 0. So this is going to become, S of x is going to become u, which is 500 times cosine of x, okay, cosine of theta, cosine of this x, it's okay, it's supposed to have been cosine of 30 here, cosine of 30 times the time. The time taken for this to come here up to there to cover that Sx is 51.76. That's times 51.76. And what do we have? So looking at that, we have been able to answer the question here. The question required us to find the distance from the bottom of the cliff to the point where the shot strikes the ground. The distance is this. It so happens to be the displacement in the x direction. and they said they should, and the time taken, we're able to find the time taken, which is 51.76 seconds right there. So you realize that here we're just playing with this equation of motion. We are playing around with it in the x direction and in the y direction, and we're able to end up with whatever we're ending up. So Roman 2, they're asking us to find the distance from the ground to the highest point reached. So the distance from the ground to the highest point reached, they want us to find this distance. Now, part of this distance, we already know this distance, part of it. We know the distance is 200 meters. So if we know this distance as 200 meters, we only need to find that other distance up, and that's it. So to find this remaining distance up, we shall go ahead and find it. Now, we already know this one here. It's 200 meters. So this remaining distance, since it is a perfect trajectory, the way you see it here, we can use one of our equations, our derived equations for maximum height. Maximum height reached if this thing is to move from here up to there. So maximum height, capital H, is going to be given by u squared sine squared theta, divide that by 2g. Our u squared, our value of u is 500, so it's going to be 500 meters per second squared, multiply that by sine squared of theta. In this case, theta is 30, divide that by 2, multiply that by 9.81. So what we have here is 31. So we have this as our figure here, that's the height we get. So in other words, this height here from here up to there is this. It is 318. It's 3185.525. Now that we know this portion, this height, by using this, then we can go ahead and answer the question. The question wants us to find the distance from the ground to the highest point reached. This is our ground, so that's the highest point reached. So from the ground, it's going to be 200 plus this that we just found here, and then we get our answer. So it means our answer will be the highest, this value of h is going to be the 200 meters. We add that extra distance we found, which is, and our answer will be, and that's our answer right there. In so doing, we have finished answering Roman 2 of the question, and that brings us to the end of this session. Thanks for watching. Please remember to share this lecture with your friends. My name is Arnold Ranga Kuramya. I'll catch you in our upcoming session. Take care.